to go through and do one of the delta math on the second level of difficulty with the differential equation. So they consider it a level 2, just because I thought this one had a lot of stuff going on and maybe could help you work through ones that you're working that on your own that are similar. So here's the problem. Particular solution. They give you this really messy differential equation. They give you the initial condition 0, 2, and then they do expect, you can tell from where it says answer, that your final answer is in y equals notation. So that is going to force a little bit of extra algebra at the end. So I put it on the screen so I could work with it. So first step is to separate. So I'm going to get the y term to the other side. So I'm going to multiply by e to the y minus 2. And that's going to go on the dy side. And then I'm going to multiply the dx on the other side. So the separating is not that bad. So moving the y piece, which is the exponent of e, to the left, and moving the dx to the right, and now it's ready to integrate. Both sides are going to integrate with a short u substitution. So on the y side, u is y minus 2. The derivative of y minus 2 is just 1, or dy, so there's no adjustment. It's an e to the u integral, which is e to the u. So you just get e to the y minus 2 on that side. The right side, the x side, is also a u substitution. U is going to be what's in parentheses, 3x plus 2. The derivative is 3. I don't have a 3. I actually have a 12. So my adjustment is going to end up being a times 4. Or you could think of it as doing a 1/3 adjustment times the 12 that's there. But you're going to end up with a 4 out front, again, because of that 12 and because of that 3. Your 4 is going to be your adjustment. And then this is going to be a u to the negative 2. So I'm going to do a little work off to the side here. Negative 2 because it's in the bottom squared. So power 1 greater divided by that power. So I'm going to end up getting negative 4 over 3x plus 2 plus c. So that is your general solution to this differential equation. So now we're going to plug our point in. So we have the point 0, 2. So when I put 2 into the y value, I get e to the 0, which is just 1. When I put 0 into the x value, I'm going to get negative 4 over 0 plus 2, which is 2. So negative 4 divided by 2 is negative 2. I'm going to add 2 to both sides. So I get a c value of 3. So now I have e to the y minus 2 equals negative 4 over 3x plus 2 plus 3. Well, now I have to get y by itself because the directions do ask to have y isolated. So I went ahead and did this one, and then I took a look at the answer just to make sure they accepted what I believed you had to do, and they did. So you're going to take the natural log of both sides, and that's what's going to get rid of the e. So you get y minus 2 equals the natural log of all of this. I don't know if absolute value bars are necessary. In their work, they actually didn't have them, so I'm assuming that you don't have to have absolute value bars, but I kind of get in that habit. And then finally, we're going to add 2 to both sides. And that, as messy as it is your final answer. The final answer is the natural log of all of this, negative 4 over 3x plus 2 plus 3. And they do not make you simplify that or put it in one fraction, plus 2. And that is what you would type in. So that shows you an example of one of the messiest differential equations that I've seen as far as separating. Very different integration techniques. They're both u substitution, but you have an e piece and you have a power piece, and then having to go through and find your c value and isolate the y.